To write down the summary, you have to read the problem very carefully from the beginning to the end. Then you need to search 3 different kinds of information. If you have a chemical reaction, the balanced chemical equation should be the first kind of information you need to look for. Then you need to search numbers with units. The last kind of information you need to search for is what we're looking for. What we're looking for is also very important in your summary, because if you don't know what you're looking for, how can you proceed? Well, for this particular problem, we do have a chemical reaction. Therefore, we need to write down the balanced chemical equation. That's the first kind of information we need to put down. Then, we need to search for numbers with units. Make sure in your summary, you have to put down the numbers with units under the proper chemical. For example, 67 liters is for nitrogen. We have to put down 67 liters below nitrogen under the chemical equation. 3.00 mole is also for nitrogen gas. Therefore, we have to put down 3.00 mole under nitrogen gas below the chemical equation. I also put down a symbol to each number with a unit, because all equations contain symbols, not numbers. If you can assign appropriate symbols to the numbers with units, it will be easier for you to find the equation to use. Then we have to put down what we're looking for as the last kind of information. We're looking for the mass in grams of sodium azide. Sodium azide is the first chemical in our equation. Therefore, we should put down the question mark below the first chemical. Well, this is a summary of our problem. In general, if you're given the information of one chemical, you're looking for the information of another chemical, stoichiometry is needed for your solution. More specifically, if you're provided the moles of one chemical, you're looking for the mass or the moles of another chemical. This is the basic stoichiometry calculation. Well, since we are given the moles of the nitrogen gas, the volume of the nitrogen gas will not be useful for this problem. Therefore, in our summary, we do not need this piece of information. Then, let me show you how to solve this problem. To solve a stoichiometry problem will be very, very easy. As I said, we can do a single-step conversion from moles of one chemical to the moles of another chemical. It can be any chemical. Since we're looking for sodium azide, therefore, we only need to convert the moles of nitrogen gas to the moles of sodium azide. This is a single-step calculation. Since we're looking for the mass in grams of sodium azide, if you remember, we can convert moles of one chemical to the mass in grams of the same chemical with the molecular weight. If we know the chemical formula, we can calculate the molecular weight. With the molecular weight and the moles of the chemical, we can convert to the mass. Well, this will be our first step, the second step, and the third step. Now let me show you the work of all steps. I put down N2 behind the unit mole, because in this calculation problem, we have 3 different kinds of chemicals. Without the chemical formula, you may not know what chemical this moles is for. Therefore, if I put down N2 behind the unit mole, it will be very clear. Then, to do a single-step stoichiometry calculation, we need the conversion factor from the balanced chemical equation, because we want to convert between nitrogen gas and sodium azide. Therefore, we may need the conversion factors between these two. Remember, these are the moles ratios. 2 moles sodium azide, 3 moles nitrogen gas. We need to pick the first conversion factor, because we want to convert from moles of N2 to moles of sodium azide. We want to cancel moles N2. Mole N2 will cancel each other, because one is the numerator, the other one is the denominator. They are identical. The unit we are going to get will be mole of sodium azide. Then we will do the next step. We should calculate the molecular weight of sodium azide. I assume you must be very skillful to do the calculation for the molecular weight. The mass is equal to the moles multiplied the molecular weight. Because this calculation is for one chemical. Therefore, if you want to omit NaN3, it's also fine. Mole will cancel. The unit we're going to get will be gram. Is exactly what we're looking for. Well, this will be the answer for our problem.